So question 5 is again on normal distribution, and this time we're looking at the length that babies are born at, and they've distributed around a mean of 51 and a standard deviation of 2 centimetres. So on the normal distribution, first of all, we need to shade the area that shows the probability less than 53 centimetres long. So less than 53 centimetres. We've got the line at 53. It's a little bit more accurate. And then from that, we're going to shade in less than 53. So it would be this part of the graph here. And then it asks the probability that a baby length greater than X centimetres is equal to the probability that they're less than 55. So if we're looking at this graph, we have less than 55, which is this whole probability here. And there's also a value that gives me the same area or the same probability when I take something this side and find the area bigger than it. So because we know that the normal distribution is symmetrical, we can use that to help us answer this question. So if we just clear off this graph a little bit, we've got less than 55, which is this section here. We want more than a value. So 55 will be the same as 47. The mean is 51, and I've gone 2 and 2, so 4 either side. So the probability of it being more than 47, which is all of this section here, is exactly the same as it being less than 55. It's the same probability each time. So X is equal to 47. And you can either show that on the graph, or you can use your calculator to do this as well. And we can say, first of all, what is the probability that the baby is less than 55 centimetres? So the probability that X is less than 55 centimetres. And we can do that on our calculator. So menu, statistics, distributions, and normal CDF. So the lower bound is negative infinity. The upper bound is 55. The mean is 51, and the standard deviation is 2. So the probability is 97.7%. And then we can say what gives me an area here of 97.7%. So to do that, let's think about what the area would be to the left. Okay, so I'm going to take that answer and times it by 100 to get my percentage, and then I'm going to do 100 minus that answer just to keep it as accurate as possible. So the percentage to the left is 2.27501%. So that's the percentage to the left of this marker, whatever this marker is, which we think is 47. So I'm now going to do menu, statistics, distributions, inverse normal, and the area to that side is 0.02275001. The mean we know is 51. The standard deviation is 2. And therefore we get the value of 47. So we now know that X, this value I was trying to find, is equal to 47. So you can either do it on the GDC or by hand. And then the second part is to calculate the probability that the length of the baby is greater than 1 standard deviation below the mean. So 1 standard deviation less than the mean. The mean is 51. So this is part 2. The mean is 51 and the standard deviation is 2. So that means that I'm essentially asked for the probability that the length is greater than 49. So for this, I'm going to use the probability that x is bigger than 49. So again, on my GDC, menu, statistics, distributions, normal. This time my lower bound is 49. My upper bound is the infinity, so this is where I use the E. My mean is 51 and my standard deviation is 2. And my answer there is 84.1% to 3 significant